Okay? So in case you need to write it down, all right, we are going to have a solid, I say line and a dashed line, but we're not going to be graphing lines all the time. So if it's a parabola or a circle, just go with it, okay? Dashed versus solid. The reason we are graphing these on a coordinate plane and shading is because we have two variables. When we only had one variable, we were on a number line. Now that we have two variables, we're on a coordinate plane, 2 dimensions. Okay. Your answer for an inequality is where the shading is. Okay? Which points satisfy all of the inequalities. So as I was coming around during your activity, one thing that I was trying to help you out with, if you didn't know where to shade, my suggestion is to pick a point, an easy coordinate. Does this coordinate that's not on the line or curve, I should say, does it satisfy the inequality? If it does satisfy the inequality, that is where you're going to shade. If it doesn't satisfy the inequality, that is not where you're going to shade. Okay? So what you did for me, like up here, that's what we're doing today with one more step. Okay? The one more step is finding what we call vertices. Okay? If there are points of intersection on the bounded region, you're going to find me those coordinates. But how do you determine where two lines intersect? You don't know how to do that, do you? Have you ever found for me where two lines intersect? Yeah, on what homework assignment? The yellow sheet, right? On the yellow sheet, that's what you did for me. I gave you two equations. You use substitution or elimination to find me a coordinate. That coordinate is where those two equations intersect. Okay? We're just building off of what we do. Okay? Now, will you always have an opportunity to find a vertex? Okay? Not necessarily. I want to show you two different cases. Like here, we have a nice bounded area, like we did with what Kaya and Emily drew up there. All right? We could have something that looks like this, where we have vertices, but we continue to grow. Or we might not have anything in common to where nothing overlaps. Okay, this would be a no solution graph right here. If your shading does not overlap, no solution. Okay, let's see, who did this one? Riley and Sydney? Was it your graph that you combined? Right, okay. This one has a solution, but these two don't intersect, and so we don't have we don't have any vertices. Okay, so that would be exciting for you. One thing that I want to talk about before we get to our examples is that you do not have to graph lines in y equals mx plus b. Please do not feel like you have to get it into that form if it is not. Okay? Whose color was 3x plus 2y is greater than 6? What color was that? Purple. Purple? Okay. If we were going to graph the line 3x plus 2y equals 6, yes, you could get this into slope-intercept form, but it would take a little bit of work to get there and you could make a mistake. Can I show you an easier way? Intercept method. If we plug 0 in for x, what does y equal? 0 is x, y is 3. We can plot that point. If I plug 0 in for y, what is x? 2. We just found the coordinate 2, 0. There's our line. So if it's in standard form, don't change it to slope-intercept. Leave it and just use the intercept method, okay? It'll give you less of a headache. All right, so we're going to go through 2 examples. Here's our first one. Write it down. X squared plus y squared equals 25. What is that? A circle with radius 5. Okay? Now my suggestion would be to think about them as equations to graph and then worry about the shading. Okay? So I'm going to graph this one in blue. So we have a circle with radius 5. And if you want to borrow some graph paper from me, I have an entire stack over there. That is not a problem. There's my circle. It's not the most beautiful circle, but that is okay. All right, and so then I need to decide, do I need a shade inside or do I need a shade outside?
Inside.
Okay, I'm hearing inside. Emily, can you tell me why inside?
Because the numbers you plug in have to be less than 25. So, every point that you plug in less than.
Okay, I see what you're saying. Let's pick an actual coordinate just to be sure. Okay, so what's an easy coordinate to pick inside of our circle? I like 0, 0. 1, 1's also easy. Is 0 squared plus 0 squared less than or equal to 25? Oh, for sure. So that's where we're going to shade. And I would shade very lightly because this is not our actual answer. Okay? So this is me shading lightly. Okay? Okay. Man, that circle is just awful. Okay. Now I need to graph 4x minus 3y equals 0. Okay, I'll do that in red. Okay, now here's a case where the intercept method is not going to work, is it? Because if I plug a 0 in for x, what do we get? 0. If I plug a 0 in for y, we get? Okay, well, we know it goes through 0, 0. But we will have to figure out the slope to graph the rest of it. Okay, so if we reorganize this, we have y equals 4/3 x. And what kind of line do we need? We need a dashed or dotted line because we have an inequality without that equals at the bottom. Okay. All right. Now we need to pick a point to figure out where we shade. Should we pick 0, 0? No, because it lies on our line. We don't want to pick that. We need to pick a point that is for sure not on the line, like 1, 0. If I plug in 1, 0, 4 times 1 minus 3 times 0, is that less than 0? What? No? So where should we shade? So we should shade above the line. Okay. Where do our shadings overlap? Where this turned dark blue, right? So what I would do is really shade that in dark. Okay? Make it obvious to Mrs. Holman that that is where your shadings overlap. Okay? Okay. Now our last step is to find our vertices. How many times do we have curves meeting around our bounded area? Twice. We have one here and we have one here. We need to find those. Do you think it's 3, 4? Okay. If you make a really nice graph and you think that you know what it is, teacher. Yes. I know they're in here next hour.
Next hour?
Yes.
Do you mind if you hold it on a minute?
Yeah, that's fine.
Thank you.
If you draw a really nice graph and you think that you know the coordinate, how could you be sure? Plug it in, but it needs to be to the equation, not the inequality, but like equals. Is 3 squared plus 4 squared equal to 25? Is 4 times 3 minus 3 times 4 equal to 0? Then that is the intersection. If you can tell from the graph and you verify, I have no problem with you skipping the algebra. Which means what's this one? -3, -4. Let's verify. Is -3 squared plus -4 squared equal to 25? Yes. Is 4 times -3 minus 3 times -4 equal to 0? Okay. If you drew a graph and it's iffy as to where those coordinates are, all you have to do is use some algebra. Okay? Right here, you already solved for y equals 4/3 x. So plug it in. X squared plus y squared equals 25. You can solve for x. Okay. 4/3 squared would be what? Oh, 16/9. Thanks. Okay, so you could do the algebra to find that x is plus or minus 3, and then do the algebra to find when x is 3, y is 4, when x is -3, y is -4. Okay, that is fine. Okay. All right, last problem. I want you to read through it. Just read. I'm pretty sure this is in your book, so let me figure out which one it is. Just read it. Okay, so this is on page 514 if you want to make yourself a note. Okay? So, we need to figure out how many cups of each drink, right? Yeah. So I'm going to call X number of cups. Is it drink A? Or drink 1? Drink X? Y is the number of cups. Drink Y. And Z is the number of cups for drink Z. Okay? All right, so we have some information. Oh, you're right. I got in a rhythm from yesterday, right? There's only drink X and Y. Whew. Okay. Can I have a negative amount of cups? No. So it is important to tell me that X and Y should be 0 or above. Minor details. Okay? We have some information about calories, right? So we have 60 calories from drink Y, and we have 60 calories from drink X, and we want 300 calories. Everything with calories should be grouped together. So 60X, calories times X, plus calories times Y, we want 300 calories, right? Do we want less than 300 calories? No, we want 300 calories or more. Max, what's your question?
Oh, B or C. I think.
Okay. Everything that deals with vitamin A, group it together. How much vitamin A do we want total? 36. How much vitamin A is in cup X? How much in cup Y? And we want to meet or exceed, so we want to be 36 or above. Do you see how I'm grouping like things together? Okay, lastly, we have vitamin C. We want 90 units of vitamin C total. Cup X provides 10 units. Cup Y provides 30 units. Okay. This is good practice for what's going to happen next week. Okay. If X is greater than or equal to 0 and Y is greater than or equal to 0, which coordinate are we or which quadrant, are we talking about? The first quadrant. Okay. 60x plus 60y is greater than or equal to 300. We first need to think about the equation. And remember, I taught you that intercept method. Okay, this is actually really nice. If I plug a 0 in for x, 60y equals 300. What does that mean about y? Okay, so y equals 5. If I plug a 0 in for y, 60x equals 300 means x is. Does 0, 0 satisfy my equation? My inequality, excuse me. 0, 0 is not bigger than 600, so we would have to shade away. Okay. This one's green. This one's blue. Here's another suggestion for you. I'm going to label this as 60x plus 60y equals 300 in case I need it later to find something. I know which line it is. $12x plus 6y, I'm going to say equals 36 because we have to plot the line first. If I plug 0 in for x, what's our y-intercept? If I plug 0 in for y, what's our x-intercept, Riley? 3. Okay. 0 times 12 plus 0 times 6 would not be bigger than 36. So we would want to shade away. from 0, 0. And I'm going to label this line 12x plus 6y equals 36. Lastly, we have this line. If I plug 0 in for x, our y-intercept is 3. If I plug 0 in for y, our x-intercept is 9. Oh. Okay. And we would have to shade away from 0, 0. So this is what's happening. We are shading this way. Okay? And what happens is we have 4 vertices. Okay? I'm going to highlight them the best I can. What color do you think will stand out the best? I'm going to do red, okay? We have this vertex right here. We have this vertex right here, this vertex right here, and this vertex right here. Those are the 4 that are bounding our region. What?
How did you get those?
So do you see how our shading's right here?
Yeah.
These are the intersection points of all the lines that we have, where we have those shading. So this is where the green and red intersect. This is where the blue and green intersect. And then we have, because we have, it can't be negative, we have where they intersect the axis. This is not a vertex because it's not by the shading. So we have a vertex of 9, 0. We have a vertex of 0, 6. If you can't tell that that is 1, 4, then you need to take the blue and the green line and do elimination to figure out what x and y are. If you can't tell that this is 3, 2, then you need to do elimination to figure out what those are. If you write them down, you better check them in those equations to make sure they work. We don't have time to do that right now, but you better. On tomorrow's quiz, if you don't, I will be very sad. Because who's to say those are going to be nice integer values? I am not going to be here tomorrow. I'll be here before school. Those of you who are going to be gone for cross country, student council, whatever, you can either take your quiz before school Monday or just take it home with you for homework when I give out corrections. Okay?
Sure?